So I'll start. So good afternoon, everyone. So it's great to be here in Text2Story workshop. Actually, it's the first time I'm presenting a paper in this workshop. So as João said, the paper is Brat2Viz. It's a tool and a pipeline for visualizing narratives from annotated texts. It is joint work with Evelin, Alexandre, Inês, Brenda, Sérgio, Purificação, António, and Ricardo. So it's a big team. We are working together, people from computer science, linguists, and we come mostly from Inês, University of Porto, also Universidade Federal do Rio Grande do Sul and the Instituto Politécnico do Mar, and importantly, Centro de Linguística da Universidade do Porto. So, so narratives, as someone said already in this workshop, they're not. It's not easy to define a narrative. There are different assertions. We are using this one. So it's a narrative text is characterized by the chronological succession of events, causality relations between the events and actors. Narratives are found in many domains, mostly literature, in particular popular culture, like popular tales, journalism, which is our main focus of attention, also in health with diaries, clinical diaries, and in finance and in other domains. So they are important, and they are an important object in our lives for communication and for representation of our wishes and our stories. So it is important to automatically extract narratives from text. So this, as you know, is a challenging and relevant task. And there's a huge lack of densely annotated data. So if you want to go into the details of the narrative elements, the links between the narrative elements, it's not easy to find data corpora that are annotated with this kind of dense annotations. So, moreover, narrative annotation efforts are complex and they are hard to validate. So if you annotate at this very dense level, it's very complex and it's very hard and laborious. So in narrative extraction from text, at least in our approach, in our project Text2Story, we identify narrative elements such as actors, events, and temporal references, their attributes, and the semantic links between them. The result is a structure that can be represented in a formal language, for example, and from this structure we can produce different representations such as diagrams or texts. So the advantage of this uniform representation is that we can have multiple ways of representing the narrative afterwards. So the task of corpus annotation is hard and laborious. Here we can see an example of a Brat annotation visualization. So this is what you see if you use Brat. Oh, sorry, I don't know if you're seeing this. This is what you see if you use Brat, and you have to label some elements, you have to link them. So this is the kind of dense annotation that we're talking about. We have actors, we have events, we have the links, so you have lots of links, and after a short period of time it becomes very confusing. So this is a very short text with lots of annotations. So to annotate, you need first to choose a semantic annotation framework, then to adapt it to a target language, in our case Portuguese. You have to avoid overloaded notation, although this is hard to avoid in some aspects, and you have to check and inspect annotation because you can make mistakes. So existing annotation tools like Brat and Prodigy are easy to use. You can find them freely, at least you can use free versions of many of them. So they are great tools, but they do not enable easy verification in this kind of dense annotation situation. So this goes alongside the visualization of narratives. So we see as a final product of narrative extraction the possibility of visualizing the narratives in different ways so that they can be shown to different audiences. And here you can see an example of a visualization. This is a standard message sequence chart that has been adapted to visualize annotation. So this is from a different work, but we are using the same kind of visualization. So actually, we developed more or less in parallel as this work by Bhattacharya et al. And another work that we found that also is using MSC or message sequence charts. So this is only one possible type of visualization. So in the annotation process, visualization can also be useful because it enables visualization of the result of the annotation, not of the extraction, but the result of the annotation. It can help the annotator to find these errors. So our proposal is Brat2Viz. It is a tool and it is a pipeline to produce visualization of narratives from annotations, which enables the human annotator to validate the labels assigned. So currently Brat2Viz is under development. So we have a working version, a demo and code that we are sharing. And it is in developing alongside our narrative extraction pipeline. So this is basically done in two steps. The first step is from annotation to formal representation, and the second step from formal representation to visualization. So dividing this pipeline essentially in two steps allows us to focus first on the part of the representation, and secondly on the part of visualization, which is done not from the original text, but from the formal representation. So Brat2Viz basically supports the high-level visualization of narrative annotation done with Brat, so it is specialized on Brat. It implements this pipeline from text annotation to visualization. Text2Story is the project where this work is included. And we are currently annotating a corpus of new stories in European Portuguese in collaboration with a team of linguists. So the main contributions are an extensible framework to generate visual representations of narratives from annotated texts, and the use of formal logic-based language, discourse representation structure, as an intermediate language to the visual representation, an online interactive demonstration of our pipeline, and available code. So in more detail, from the Brat tool, the Brat annotation tool, we obtain a .ann file. So here in the Brat annotation tool is where all the human work is. And this is the result of Brat. So basically, this is a text file with a predefined structure according to the semantic framework that we define here in the configurations of Brat. And this then is automatically transformed into a discourse representation structure, which can then be represented in multiple ways. And we are showing MSC representation, message sequence charts, and knowledge graphs. So one important part is the annotation scheme, which has been carefully defined by us using standards. The annotation is done in 3 levels: referential, temporal, and semantic role labeling. We are using ISO standards that are mentioned here, and we have to do some adaptations of these standards, including in the number of tags and the types of attributes due to multi-layer annotation, properties of the Portuguese language, and also the genre of the corpus that we are using, which are news. So these are normal adaptations that have to be done, but mostly we are using the standards that are defined. So in our annotation scheme, we essentially have 3 types of tags: actors, events, and timex3 for temporal expression. So actors is like a man or an object like a pistol. Events are like robbed, and timex Friday and yesterday, 2020, etc. And we also have attributes with different values for these different categories. Then we have linkage between these objects. We have between the actors relations like referral, like synonymy, antonymy, hyponymy, etc. Object relations, which are from between linguistic units, and these represent things like, for example, here you have, this is in Portuguese, but this is the assailant, this is the thief, and here you have a link saying that they are the same. So this kind of relation is very important given by the annotator, because it allows us to have information about co-references and different ways of addressing one particular actor. And then we have relations between events and actors, and these are the semantic roles links, and these are important to associate the actors with particular events, like here crime and occurred, the thief escaped, etc. And then we have temporal links that account for the chronological ordering of the events. So all these things are annotated manually, and then what we do in Brat2Viz basically is to first transform this into the representation language, which is DRS, and then to visualize. So the two steps of the pipeline are implemented as two modules. One is Brat2DRS, where we go from annotation files to the DRS representation. And the second module, DRS2Viz, where we go from the formal representation to the visualization, and this is deployed as a web application. So in the first module, we parse this .ann file. So you can see here a .ann file. This is produced by Brat from manual annotation. In each line, you have one particular tag. There's an identifier, the tag, the span, and the text that corresponds to this particular annotation. And you have here attributes for this actor, then you have an event, you have attributes for this particular event, etc. So this is only a small part. So a very dense annotation gives a large number of annotations, a large file, or relatively large file. This is only a small snippet. So from this, we build a dictionary with the linguist elements found, and this dictionary is going to be used to construct the representation, the declarative representation of the narrative elements. So then we have to do things like assigning symbolic variables to each event, etc., so that everything is correctly described in the DRS representation. And then we transcribe to first order logic and DRS. So actually DRS is a specific type of first order logic with some extra declarations. And here is a small snippet of what DRS looks like. So you have an event A. So the information about what is an event, the event A is given before. And then this the event class of A is occurrence, the tense of A is past one, etc. And then you have here a semantic relation with agent T3, which is defined as something. Here we don't see in DRS, but we see here in the .ann, the T3 is a man who is an actor. So the discourse representation structure is something that has been around for a long time. It has been proposed in the linguistics domain, and it allows us to declarative represent discourse. So in our case, we are using this particular structure to describe events, properties, actors, time expressions, or the things that I have referred before. So the DRS is generated automatically from the .ann, and it is a high-level abstract representation of the narrative. So since it is a high-level representation of the narrative, it can be used then to be transformed to different types of representations, so visualizations, or even to generate text in another form, not the original one. And it doesn't require to go back to the original text. Besides, it can be used for reasoning. We are not doing that currently, but we can use the statements in the DRS to perform reasoning at a logical level. So, and this is again the same example of DRS declaring one event named A and some attributes of the event. So the DRS2Viz module, the second module of the pipeline, has this parser component and the visualization engine. The input is DRS, the output are the visualizations in the web browsers. Currently we have MSC and knowledge graphs. Actors are represented as nodes in these two visualizations, and events and relations are represented as links between nodes. So the parser basically extracts these actors, events, and relations and puts them in the adequate structures, and they keep track of the identifiers and the lexical items that represent them. So basically here you see this example, and one important thing to say is that when we are visualizing is that we have to identify the actors for the nodes, the events for the links, and we also have to identify different words corresponding to as the same actor, because in the text the same actor is referred to as different with different terms like thief, man, assailant. So they are grouped together to be in the same node. So we are not selecting for now a single label for the nodes. So basically here we have we can have a group of labels for one particular node. For example, here we have a couple, who, them. So these are different labels for the same node. So this is a message sequence chart visualization. So here we have the nodes, the actors that are involved in this particular narrative. Then there's a timeline that goes from top to bottom. And the horizontal lines represent links, relations between the actors, and they can represent events, and sometimes they can represent relations, like here you have part of or meronymy. So these come from different annotations. So, but the events are here, so you can see that a man robbed in Avenida da Liberdade, which is in Lisbon, and he robbed a couple who was inside a car, and this helps the annotator in particular to visualize what has been annotated. And in this case, you can see potential problems that can happen. For example, here you have in this node a couple, and then here you have again a couple who was inside the car, and this seems to be the same actor. So this is a hint to fix the annotation, go back to Brat and fix the annotation. So this is the kind of information that we want the annotator to get from the visualizations. And the other form of visualization that we have is the knowledge graph. So the nodes you have, in the nodes you have the actors, and the links you have the events and the relations. And from here you can get essentially the same kind of information. So this is a very small story, and it gives this particularly small representation. But if you have a not so large text, you can get a quite large graph or MSC chart, which doesn't fit the screen, so you have to navigate in that screen. So to conclude, Brat2Viz is a tool and a pipeline that visualizes narratives from annotations produced in Brat. It is a two-step modular pipeline, from narrative annotations to the DRS formal language, and then from DRS to visual representations. And currently visualize the narratives as message sequence charts and knowledge graphs. So if you want to try or to extend Brat2Viz, there's an online demo in this on this URL. You can try our example. So because you need to have them annotated in our semantic framework. You can check out our project webpage and get in touch if you are interested. And you also have a GitHub repository in this link. So the links will be available. They are in the paper. You can find them in the paper, and they will be available in the presentations as well. So for future work, this modular pipeline enables extension and adaptation to other scenarios. Other visualizations that we are currently working on, such as timelines or story trees or icon strips. Other types of representations, for example, simplified textual narratives. So it's a kind of transformative summarization. The annotation scheme can also be adapted to other needs, but this requires more effort. And narrative extraction algorithms may also be plugged as automatic annotators. That's actually what we are doing. So it's more or less the same pipeline, but in the beginning of the pipeline, instead of having the human annotator, you have these automatic narrative extraction algorithms that output the annotation in the same format as the Brat annotation, and this automatically produces the visualization that we have. And if we have different types of visualization, we just have to choose one of them. So thank you. Before I finish, if I have some more time, I can show you just quickly, can give you a view. So I don't know if you're seeing the...
Yeah, we are.
You are? Okay, great. So let me just... Okay, so this is the tool. So this is actually the example that we have in the paper. So this is a very small example that was produced for the paper based on a real one. Here you can try other examples with more text. So for example, this one, actually this is the original text. So here you have the annotation. So as you can see, it's a lot. So this is what comes out from the manual effort. The aim of extracting narratives in our project is to automatically obtain this from the text. Okay, so these elements, and here you have the actors, the events, the attributes, the time references, etc. Some of these elements are quite hard to obtain, so these represent many different problems and many different difficulty levels. Then you have the DRS from this. So this is obtained automatically from the annotation. So here you have first order logic representation and DRS, and you have the identifiers, etc. So actually you can use this, as I said, for inference, because they're basically first order logic statements. This is the MSC visualization, where you can see that now this is a bit larger than the example that I've shown. And this was obtained automatically from the DRS, and you have the graph representation. So this is a knowledge graph. We are using existing libraries for visualization. So we're just putting the information in the correct format so that this can be visualized. And we are currently working in different kinds of visualization. So thank you. Now I finish. Thank
you.